And please understand why we are talking about decision making today is decision making is the key component of any agent's behavior. So whenever the agent has certain open nodes in its open list, if you are talking about search based agent, then there is a decision that the agent needs to make out of those nodes which are sitting in the open list, which node it needs to open next or review next. And this particular thing is nothing but a kind of decision the agent is making. Similarly, we may talk about reasoning process which uses the inference rules or inference mechanism. In the inference mechanism also, if you are doing forward chaining, you need to select the clauses which can fire the head of any particular rule so that you can infer the tail using some sort of a mechanism that can do the substitution properly. Okay, so we have learned that in all these AI mechanisms which try to find out a solution path or tries to prove certain unknown fact about the world, they require to take decisions, and hence the decision making process is a key process to any AI procedure. Okay, so purely logical approach could be uh, to have a risk falsehood. A25 will get me there on time or leads to a conclusions that are too weak for decision making. Okay, so what does these two things mean? So I'll just brief out you what does these two means. Risk falsehood here refers to, so this statement or this particular decision, so this is this particular thing which I'm underlining is the decision that you take. So A25 will get me there on time, that is 20, if I leave 25 minutes early to my flight time, then I can reach the airport. Okay, this is the decision. Now this decision actually can be a false decision, so there is a risk of this decision being a false decision, that is I may not actually reach in time to my airport if I leave 25 minutes early. And this may happen due to all the kinds of uncertainty that we talked about in the decision making process. If I do not compensate them, then there is a risk of being a false positive decision. Okay. Next thing is, whenever there is uncertainty, this may actually lead to conclusions that are too weak for the decision making, because in logic, or if you follow a purely logical approach and you consider that everything is either true or either false or unknown, so these are the three things that generally a logic system assumes. Either a thing is a falsehood or it is false. Okay, either it is true, either it is false, it is unknown. It can be either true or false. But in uncertainty, you are not always sure about either something is truly, something is false completely, or something is unknown completely. There is always a attached risk involved in saying that something is false or something is true. So if you do not compensate this likelihood of being false or being true, the decisions that you are making, they may either be too weak decisions so that they can easily be tested out in the real application. यानी मैंने एक डिसीजन लिया है, लेकिन जब मैं वो उसको अप्लाई करूंगा रियल सिचुएशन में, तो वो मुझे desired result नहीं देगा. That are referred to as weak decisions. And risk of falsehood means that whether the basis of the decision on which I'm taking my decision, they themselves are not correct, means the decision that I'm going to take is going to be definitely not accurate decision, and I won't be able to do a rational design of an agent. Okay, so see, this is A1440, that is you start 1440 minutes early, which is a reasonable thing. But then if I do this, I have to stay overnight on the airport, and if I stay overnight on the airport, I may actually uh, it may be costly, it may be not proper for me to have a proper sleep, and there could be multiple reasons. So I may achieve my goal, so by A1440. that is to start 14-40 minutes early. So this is what we mean by weak decision making. I can reach the airport, so reaching the airport is achieved, but after reaching the airport I have to stay for a lot of time, because half an hour I can reach, 25 minutes I can reach, rest of the time I need to just spend on the airport, which may be troublesome for certain agents, which may actually utilize that particular time for doing certain more constructive activities, which may be more productive otherwise. Okay, so 8:25 will get me there on time if there's no accident on the bridge and it does not rain and my tires remain intact, etc. So there are a lot of ifs and buts. If 8:25 can work, but then 14:40 will definitely work, क्योंकि अगर मैं एक्सीडेंट हुआ तो भी उस थोड़ी देर बाद वो क्लियर हो जाएगा and I can reach the airport. If my tire gets flat, still I can manage to correct that particular tire and maybe reach the airport in time, because I'm starting so early. But starting so early is not a proper decision. We also know, we human being, we know that इतना जल्दी एयरपोर्ट में जाके क्या आप झाड़ू मारोगे वहां पे, पता नहीं क्या करोगे. So that's a kind of thing that you need to be worried about. So if I had some mechanism of modeling the uncertainty of whether there would be an accident or not, whether there would be rain or not, whether there would be a tire break at my tire flat tire getting into the scene or not, all these things if I were able to model, okay, then my decision would have been much more concrete and much more, I would be much more sure about the decision that I'm making. And hence the need of modeling uncertainty arises when you are designing an AI agent. So not always the world is certain around you. The environment may not be certain, the sensor may not be accurate, the sensor may be giving you wrong prediction about the values of the environmental variables, and there could be very much complex environment and I may not be able to have the time or the resources to model it certainly, and that's why there could be uncertainty creeping in the environment. Now what are the different methods of handling the certainty? क्या क्या mechanism हो सकते हैं using which I can handle the uncertainty? So there could be various sources of uncertainty, हमने देख लिया. Now we are trying to understand what could be the different mechanisms using which I can handle the uncertainty. So what they are saying is you can have a non-monotonic logic, that is, assume my car does not have a flat tire, assume 825 works unless contradicted by evidence. Okay, so we can actually go about and using the same logical method. So non monotonic logic यानी आप सिर्फ जो भी default method use करो, हम assume कर लो जो variables आपको पता नहीं उनको assume कर लो. So you say that my car does not have a flat tire, लेकिन actual case में flat tire हो सकता है. Okay, लेकिन अगर flat tire हुआ तो you plan a contingency, and that is what is referred to as online decision making or online mode of changing your plan. So you plan for all the causes that may or may not happen, लेकिन ये सिर्फ पॉसिबल है अगर आपका जो प्रॉब्लम है वो कॉम्प्लेक्स नहीं है. तो if your problem is quite complex, then this may not be going to work for you, because the complexity involved may require you to design too many number of plans which you want to fire when a certain scenario occurs, and those combinations are very much pretty expensive, because finding so many plans at first place is time and space consuming. Remembering all those plans require a lot of memorization abilities to your agent, and although you may have those memorization abilities, although you may have those plan designing abilities with you, still when it comes to go for alternative plans, it's not always possible to rework a particular action, because whenever you are doing an online learning of a plan or online implementation of a plan, it may require you to do certain actions taken aback. That is, you need to backtrack certain actions, and that may not be possible in the real world scenario. Okay, for always. Okay, it's not impossible. Definitely it is possible to do certain actions backwards, but maybe certain actions may not be in real world be backtracked, and that's the reason this particular mechanism does not suit for all prevailing decision making in uncertain domain. Okay, so you may actually be compensated using, so I'm not talking about this middle part. I'm directly jumping on the probability theory because it gives a very good model of uncertainty. And if you remember your I guess mathematics 3, applied mathematics 3 or applied mathematics 4, you learned about probability distributions, and how the random variables are uh, represented using probability distributions. And you will understand that the basic necessity for probability theory was to be able to model the uncertain behavior of certain variables that we are talking about here. A25 is a variable that says, can I reach to the airport in time if I start 25 minutes early to my scheduled plane time. Okay, I if I use probability theory, I may come up with certain degree of numeric assistance to this decision, saying that 0.04 is the probability of reaching 25 minutes early, leaving for the airport. And what does 0.04 means? 0.04 means the probability of reaching to the airport if I start 25 minutes early is very weak. I can understand from, so you know that any probability number is between always 0 and 1. As when it goes close to 1, it is more certain to occur, and when it comes more close to 0, it is less certain to occur, that particular event. So here the event A25 is very much less certain. So I can have, based on probability number, some sense of how good I am at that particular plan. So if I attach these probability numbers with my decision making process, or I consider, I give importance to these numbers, these numeric weights, that I may refer to them as weights, to my events, then I will be more and more certain about what could be the right plan, what could be the right decision, and the decisions that I'm making may be more and more rational. Okay, so probability assertions. Probabilistic assertions means assertions which are supported by some probability number. So assertions in logic tell you that something is a fact, but assertions in probabilistic domain or a probability domain does not tell you what is a fact, but it tells you what is the mm, degree of correctness of that particular assertion. Okay, so the probability assertion summarizes the effect of laziness and effect of ignorance. So these two things are compensated by probabilistic assertions. The laziness means failure to enumerate exceptions, qualifications, so all the kinds of things which we may not be, due to complexity of the problem, compensate or know about, and they are just unobservable because of the lack of power to handle all the uncertain variables, all the variables together. So laziness is compensated using probability theory. Ignorance can also be compensated. So अगर मेरा environment ही unobservable है या semi observable है, partially observable है, in that sense this ignorance can also be compensated using the probabilistic assertion. So the assertions or the logical representations which use probability for understanding how probable or how much uh, true the particular fact is. Now, for instance, what they're writing here, PA25, this symbol, it says that given the fact, so probability PA25 given the fact no reported accidents is equal to 0.06. Now, if you see the example before, we were saying that PA25, the probability that I reach airport if I start 25 minutes early to my plane time